Let's determine the equation of a straight line. Consider the following graphical representation of some function f in a two-dimensional Cartesian reference frame. We aim to formulate an equation that describes this relationship between the dependent variable y and the independent variable x, in other words, a function, here designated by f and represented in the Cartesian reference frame. So we can say that f of x is a function of y. The general formula for the equation of a straight line is y equals a times x plus b, being a the slope or gradient and b the value of the ordinate when the abscissa is 0. The expression of the slope is derived from the previous expression, giving the ratio between the change in y and the change in x. This parameter gives a measure of how steep or inclined our line is. So, the first step is to choose any 2 points within the graph of function f. But why 2 points? Because a straight line is defined by at least 2 non-coincident points. To simplify things, we will choose the origin and the point having 2 integer values for the coordinates. Next, we will find our slope based on these 2 points, with the above presented expression. The change in y is 1 minus 0, and the change in x is 3 minus 0, which results in 1/3. Note that we could also have chosen another point other than the origin. For example, to better illustrate and visualize the slope, let's consider 2 new points in which P1' coincides with P2, previously defined, and the other, P2', has coordinates 6 and 2. Since this is a straight line, we will obtain the same slope no matter what points we choose from the graph of function f. Based on these points, let's draw the change in x, also called run, and the change in y, also called rise or fall, and isolate this triangle. We can draw some conclusions out of this triangle. First, we can see that the change in x is bigger than the change in y. For every 3 units we run in the horizontal direction, we rise only 1 unit in the vertical direction. The other conclusion is the fact that for bigger positive values of x, we obtain bigger positive values of y. This is equivalent to having a positive value for our slope. In the expression of the slope, the order we choose the points is arbitrary. We could have changed the order of the points and obtained the same result. For instance, changing the order of points P1' and P2'. We would obtain negative results in both the numerator and denominator, which would eventually give a positive slope, the same as the result with the previously established order of points. But now let's consider the original set of points to determine the equation of the linear function. One parameter is left to determine, parameter b, which is the value of y when x is 0, or it can be seen as when the function intersects the axis of ordinates, assuming the value of y in that intersection. In our exercise, the value of b is 0, since the function intersects the origin. Using the above presented formula for the equation of a straight line, the equation of function f can be determined. Substituting the values of a and b, we finally have our result. Function f of x is equal to 1/3 times x.